Hello, and welcome to our introductory session of Data for SaaS. My name is Grant, and I'm a specialist solutions architect here at Amazon Web Services. In this series of recordings, we'll explore the importance, relevance, challenges, and concerns that you need to consider with data in a software as a service or SaaS implementation. This is the agenda for today, and for the next 25-30 minutes or so, we'll cover the following topics. We're going to look at an overview of what SaaS is. We're going to introduce some key terminology, some core themes we're going to explore during these sessions. And we're going to finish with a typical architecture walkthrough of a SaaS implementation that would run within Amazon Web Services.
So let's start with an overview of the Data for SaaS SC.A.L.E sessions that we're going to deliver over the next few weeks. We're going to be offering a series of short technical videos with content aimed at an advanced or expert level of understanding. We're going to host content on this YouTube channel that you're on now. The content will be generally up to 30 minutes in duration, and we're going to post on a regular basis. Any coding examples, blueprints, reference architectures, links to blogs, and so on, we're going to post on GitHub, and that's the QR link showing on the screen there. We'll also have the links in a subsequent slide at the end, and future subject matter will be driven by your feedback and comments. We've got a series of themes and content we're going to deliver. Obviously, we're keen to add content to it based on your feedback. So if you've got any challenges, features you'd like us to cover in future, concerns, or just best practice, how would we choose to approach certain things, by all means, let us know in the comments, feedback what you want, and we'll look to drive some sessions in future around it. And now we're going to move on to some of the key terminology that you need to understand when talking about SaaS terminology, SaaS concepts, and that you become familiar with throughout the rest of these sessions.
So first and foremost, what is SaaS, or software as a service? It's not just the technical implementation, it's also a business strategy. So the emphasis and the mindset within a company offering SaaS has to center around the creation of a service experience for customers that focuses on zero downtime for the tenants or end customers, regular updates, and a closer connection with the customers. So you've got to design a architectural and operational footprint that can promote continual evolution and be able to respond rapidly to market demands and what your end customers are asking for. And there's certain key characteristics of a SaaS solution that need to be addressed. It's the idea of multi-tenancy. So how do you handle multiple customers best? Are you going to share resources? Are you going to have separate resources for them? You need a well-defined way of isolating your tenants, both from a data privacy point of view, from a performance impact point of view. You want a consistent and easily reproducible onboarding model that has low operational overhead. You don't want to spend a lot of time having to do the same things over and over again to bring a new customer on board. You want it to be scripted, automatic, straightforward, and relatively cheap to ramp up. Looking at some design principles of SaaS, we're saying there's not one size fits all in SaaS architecture. As businesses change, end customer demands also change. They may start out as a relatively small greenfield or SMB type business, small medium business, and then hopefully, ideally, they will grow to be enterprise class, and the consumption of SaaS software services will grow and possibly shrink over time as well. So the SaaS architecture that you develop needs to be secure, efficient, and scalable. It needs to be secure in that tenants are isolated from each other. needs to be efficient so that you're not wasting resources, because any resource wastage that you have will scale and get worse over time as you onboard new customers. So you want that to be minimal, low, non-existent as possible. So as you scale your sales growth, you're not scaling your costs at the same time as well. But of course, you want to be able to design for growth. You want to be able to have the ability to embrace success and say, our software product is going to be really successful. We want to be able to grow, get more customers on board, and grow our business accordingly. Looking at one of the core components of SaaS, it is tenancy, or what is a tenant? So in the essence of SaaS, a tenant refers to a single instance of a software application that is running and being used by a specific customer. Each tenant in the SaaS system is typically isolated from each other, meaning the data, configurations, and customizations are not visible or accessible by other tenants. And there's a number of strategies and mechanisms available to us to isolate tenants, and a number of things that may influence which strategy we choose to follow. We're going to explore some of these tenant deployment models on the next slide. So how do you handle multiple tenants on a software as a service implementation? The simplest approach is what we call the silo model, where in this model, you store the data for each tenant in its own separate database instance. So under the silo model, the storage of the tenant data is fully isolated from any other tenant, and all the constructs related to that tenant are considered to be unique to that client. Conversely, at the other end of the spectrum is a pool model. In this case, you're storing data and sharing resources for all tenants in a common set of tables within a single schema, where you may be able to use some degree of row-level security to isolate tenant data within a single table. So, for instance, you may be able to say tenant 1 in this example can only see rows number 1 and 3. Tenant 2 can see row number 2 and 4. And in that case, shared table, but each tenant can't see the other data at a row-by-row level. Conversely, in the middle, we've got a bit of a mix of the two, which is the bridge model. Concept behind the bridge model is that you store the data for each tenant in either a separate database within a single database cluster, or in separate schemas within a single database. So it's a bit of a compromise between silo and pool. What it does, it moves all the tenant data into a single database, but you do get a degree of variation and separation on a schema by schema basis. However, for many organizations, the choice of do we go silo or pool is not as straightforward as that. Your tenants and your business circumstances may change over time. So one potential compromise could be that tenants may start out in the pool model, where they're starting out using a small amount of consumption, and as they grow in success, as they want to use more of your services, you may then want to consider moving them to a bridge or silo model, as they're using more of your services and they want a higher degree of customization or performance. So why should we separate our tenant data at all? In essence, it comes down to trust. You want to be able to reassure your customers that the data is private to them, that it can meet any regulatory or compliance requirements that either they or their industry or territory may have. And what we should be doing is looking on tenant isolation as an opportunity rather than a cost. Because worst case, if we do leak tenant data, either from one tenant to another or even externally, then the financial or reputational penalties that you can encounter can be very severe. And if your customers don't trust you as a software service provider, then it may be impossible or very difficult to regain that trust going forward. Some of the ways that we control or identify from a tenant by tenant point of view who can do what is the tenant identity. And a tenant identity or context is made up of the user ID, i.e. who they log into a system at, and the context of what they can actually do when they log in. So we call that a SaaS identity. A common way of handling that is via a JWT or JSON Web Token, which is a open standard used to create a compact self-contained token that can be transmitted between various components and up and down the application stack that defines for this particular tenant, they can do function ABC, but not function XYZ. And that's certainly valuable both from in this example, a API gateway point of view, but also when it comes down to shared services such as a logging mechanism or tenant metering mechanism, or conversely, when it comes down to the tenant by tenant data access layer. You want to know that the tenant one token will give tenant one access to their data at a data access layer, but not tenant two. So it's good for control, it's good for identity, it's good for separation of resources and ability. So what are some of the challenges in handling tenant data in a SaaS implementation? You've got concerns around security, so tenant isolation, depending on the type of tenant model you chose, especially if you're looking at the pool approach where you're pooling resources together. We talked a bit about governance, compliance, access control requirements. Cost of servicing, so you want operational and cost efficiency, so bringing on new tenants is not exorbitantly expensive. And you want to be able to perform single tenant operations in a multi-tenant environment. For instance, can you do single tenant backups and restores? Can you monitor a single tenant? Can you identify what tenant A is doing versus tenant B? And of course, you want to be able to scale your software seamlessly, because you want to monetize your software appropriately. You want to introduce new features and business insights, and you want your SaaS customers to increase their spend with you to bring in more revenue. So in the next few slides, and indeed all of our future sessions we're going to deliver, we're going to explore a set of themes based around these data challenges that we're going to go into in the next few slides. And we call these themes SC.A.L.E, which is an acronym that stands for scalability is the first letter. So are you able to use your computing resources efficiently to meet the system requirements and to maintain that efficiency as your demand changes? So in the case of a silo pool model, where each tenant has their own separate set of resources, it's great. There's no cross-tenant resource impact because they're all separated. Conversely, in the pool approach, where you're sharing resources, there's quite a heavy or high impact on cross-tenant resources because they're sharing services. You've got to somehow separate what they can do and isolate them as best you can. And the same way for tenant level tuning. Again, silo model, easiest to do, everything separate, separate database, separate components. In a pool model, it's not really possible because if all the tables are shared by all the tenants and all you've got is granular access at the row level, then you can't easily control the level of performance that tenant A can have over tenant B. And conversely, can you rebalance your tenant for performance? So if a tenant wants to scale up their consumption or scale down their consumption, can you enhance or degrade the abilities or the consumption model of your system going forward? Moving on to the C in the word scale, that stands for consistency. So how do you know that your data changes have been made successfully and they're going to persist? How do you know that your data is not duplicated, that you do only have a single source of truth? Or worst case, your data is duplicated and the values are different. So this comes down to transactional durability and transactional consistency. So in the case of any sort of two-phase commit or separate data stores, how do you know that your data has been successfully written to data store A and data store B, and has successfully been written to both and not a partial commit in one and a failure in the other, and therefore you've got data inconsistency. So that's the transactional side of the SCA.L.E acronym. Moving on to the A, that's availability. This is the ability of a system to recover from infrastructure service failures, to be able to dynamically acquire computing resources to scale up and scale down, and to be able to mitigate disruptions as best you can due to a misconfiguration, a network issue. This could be along the lines of doing tenant level backup and recovery. If you get a request from a tenant to restore their data, and they're in a pool model shared service, for instance, then how can you bring back individual rows of data to the same tables as other customers are using without effort? Far easier in a silo model where you can just restore an entire database back. Easier in a bridge model where you can restore back separate schemas into a single database. And tenant level point-in-time recovery. Same sort of problems and challenges where can you bring a tenant back to an earlier point in time if they have some sort of logical corruption issue sort of requirement to rewind their changes back to a certain point in time. L stands for latency. So are your tenants happy in terms of performance? How do you know they're happy? If they're not, what can you do about it? This comes down to having tenant-aware metrics and insights. So having the right telemetry to know what your tenants are doing, how much of it they're doing, and what the recommended or guideline response time should be. So this could be useful for a consumption model where tenants are paying based on API calls, for instance. It could be useful where you've got a quote noisy neighbor mitigation where one particular tenant is a heavyweight user of or consumption of resources, and that's got a negative impact on other tenants. Do you know who the noisy neighbor is? Can you identify them? Or do you just know that everything's running slowly on this particular shared resource and you can't easily narrow down to who it is? And on the other side of the coin, it's are you able to vary performance on a tenant by tenant basis? So as I mentioned before, if a tenant wants to pay for more consumption of your services, can you then raise them from a bronze to a silver type offering? And by going from bronze to silver, they get access to 5,000 API calls an hour rather than 2,000, for instance. Can you change those knobs and dials to then give them that level of increase in performance? And finally, on the SCA.L.E keyword, evolution. So depending on the age of your SaaS application, have you been through the journey, or can you survive going from client server through API traffic, microservices to whatever the next new technology is that's going to come along very soon? On the database side, will your SaaS database evolve from, if you're using a commercial relational database, perhaps looking at open source offerings, Do you need to look at purpose-built data stores? Do you need to contemplate going to serverless databases to give more granular performance to each tenant so they can scale up and scale down based on their demand requirements? So these scale themes are what we're going to look at during these upcoming sessions. So the next ones we're looking to do around the scalability theme is we're going to talk about connection management for relational databases. We're going to talk about some considerations for tenant portability, consistency. We're going to look at a deep dive in transactional durability and consistency, availability, backup and restore, so tenant by tenant backup, restore, and so forth. Latency, tenant performance management, metrics, telemetry. We touched on that. And evolution, talking about how you can introduce a shared data lake for the SaaS company that brings in all the separate tenant by tenant data, so they get a single dashboard view of all the tenants, their usage, their consumption, to help them plan out their capacity and future growth requirements. So next we're going to look at a typical SaaS architecture through the, if you like, through the lens of AWS services. So apologies if all these services aren't familiar to you, but by all means, you can go away and look at them after the fact, and we'll have the reference architecture uploaded onto the GitHub link as well. So starting at bubble 1, this is our user who initiates a tenant provisioning or product provisioning request. That then talks to bubble 2, which is our Cognito identity provider service. And that not only identifies who user 1 is, but also what they can actually do. So this is where the JWT token comes in to say tenant 1 has access to these services, they can do these particular activities. That then talks via a API gateway to a bunch of Lambda services, and these Lambda services can do such things as listing a tenant, creating a tenant, user admin features, and so on and so forth. Bubble 4, that then comes down to the administration APIs for common tenant services. That then goes over to bubble 5, which is the identity and access management that the Lambda APIs may need to say, can that particular API request have access to these backend services? Bubble 6, the Lambda services may need access to some persistent data store, so some reference data, some lookup information that could be stored in DynamoDB or on our S3 simple storage service. Once you've got access to this data store, then we look at bubble 7, which is running through a workflow to actually do any provisioning, and that could be using CloudFormation templates. That could also talk to the data plane to say, I need some reference data for my cloud provisioning, so I know what the tenant information is. They want a small versus the medium versus the large. They want access to this, but not that. That's described in step 8 and step 9. Coming across to bubble 10, this is if the SaaS product has any additional resources that are specific to the SaaS product that it may need to have. That's described in point 10. That could be link outs to other AWS accounts, other services. All of these communicate via bubble 11, which is a communication pane, in this case, a simple notification service that via step 13 comes all the way back to the user to say, yes, we're deploying this, we're doing this for you, it succeeded, it failed, here's a problem, here's a confirmation. Bubble 14 is around the logging and monitoring phase. So we we log the fact these requests came in, we update audit trails, we push stuff to CloudWatch so that you can see what's happening in your SaaS system going forward. And then finally, step 15 is where it all finishes. So again, this infrastructure will be uploaded to GitHub. It's fairly standard. There's more information there about it. Moving on to resources. So again, this is the QR link and the web link to a GitHub repo. So we encourage you to navigate through that at your leisure, to have a look at the code and the resources that are on there. That will only grow over time. There's a link to our AWS blogs. Great resource, great way to search for key facts, key services, key things people have written. And also, finally, our well-architected framework, looking at the framework through a SaaS lens, so with a SaaS theme on the framework, best practices, things you should consider, things you shouldn't consider. And so going forward, we look forward to seeing you on our future sessions. And as I said in the very beginning, we value your feedback and your ideas for what we should produce in future. We'd love to hear about any sort of future subject areas or challenges that you would like us to cover. Thank you for your time, and I look forward to seeing you again in another session.